Welcome to the 12D model Rivers Interfaces training. As we go through this training program, we're going to follow the course notes called 12D Rivers that you're going to find in the documentation folder on your 12D distribution CD. Now we'll minimize these course notes for the time being and get straight into 12D. Double-clicking on the 12D model icon on your desktop will bring up our project selection dialog, and we're going to start working in our courses folder. To find that, we'll do a left mouse click on our folder icon, move into our version 8 folder, courses, and down into the Rivers folder. Now you will find a completed project in here. We're not going to use that. We're going to create a new project, so we're simply going to open our working folder. Now this working folder is where when we do an export, the files will go to that working folder, and if we're looking for any input data, it will first look inside that working folder as well. Now we have to give a name to our project. We're going to give this project the name Geelong after the area where the creek goes through, and select Proceed. 12D will open up, showing the splash screen to begin with, and present us with a plan view and our setup project details. These project details allow you to put information such as your project number, your starting drawing numbers, designers, datums, that type of information, mostly for record keeping, but also this information can be included on your drainage title, on your plan title blocks. So we'll select Set for that and Finish. Now we're going to maximize our plan view window so we have a little bit more area to work in, and move aside our recalc. We've got 12D all ready to go, and read in our survey data. Our first step is to import some survey data that we will use to create our ground surface or TIN from. Now the data has come in the XYZ format. We'll go up to File I/O, move across to Data Input, and go down to XYZS format. The file that we're looking for is called geelong.dat, and let's take a look at this before we read it in. So selecting the folder once again, come down and select Open. And by the way, selecting the file here does absolutely nothing. When you select Open, what you open is the file that's listed up here in the dialog box. So once again, select Open, and you'll see that we have our X, Y, and Z values followed by the string value. These string values are survey codes, and when you have consecutive survey codes, they become a break line inside 12D. So this first break line will have 3 points on it called 4, and the name of the string will be called 410. Then we'll have the 903 as a separate string. Then we would have a isolated spot elevation by itself. Then we go back to 413 and 410. Now an important note here is that this will create a new string with 3 points on it called 410, completely separate from the break line up above. And same down here, because there's a blank spot between this 410 and this 410, this 410 will be the start of another break line. So any change in the consecutive points will create a new break line in the XYZS format. So we'll close that down, and we're ready to read this in. Now the data has to be stored inside a model inside 12D, so the default model for this one, we'll call that survey. Now we're fine to use superstrings, and if we would like to see the data immediately added on to our view, saving us the trouble of using the plus button, we can say add this on to view number 1. View number 1 comes from the number that you see down here in the corner. And then we'll select read. And then we can finish with that. And you can see we have our survey data in front of us. Zooming in a little bit closer, we'd now like to take a look at the elevations there. We can toggle on our Z values, and you'll see that there's an elevation associated with the spot levels, and there's also elevations along our break lines. If you'd like to see the exact location of these points along the break line, we can come up and toggle on our vertices. Now in cyan here you can see the exact location of these X, Y, Z values. Now that we have our survey data inside 12D, we're ready to create a TIN. To do this, we'll go up to our tins, come down to Create, and select Triangulate Data. The first thing it asks us for is a function. The idea of a function is that if we're going to be editing the survey data, we can quickly regenerate our tin by using the recalc options on our recalc menu. So we'll do that. We'll call this survey. Hit the Enter key. You'll find that after we enter data into 12D, hitting the Enter key is a good idea because it validates the data. Also, it will often fill out other fields inside the dialog. So for example, if I call this one Survey again for the name of my tin and hit Enter, it fills out the name of the model that tin will be stored in. Now, every tin inside 12D must have a name, and by default, we store these tins inside a model that has the prefix tin. Now, this isn't required, but it's definitely a 12D convention, and it helps keep your data organized. Now, during the triangulation process, especially if you have contour data, you are going to want to use your remove bubbles. What remove bubbles does is it tells 12D to take only 2 points off a break line while creating a triangle and go somewhere else for the third. Now we'll do the triangulation and you'll be able to see just how this works. The next thing we'll do is move to our second tab and specify the data that we're going to triangulate. Now because this data is all in one model, we're free to come across and use the model selection called Survey, and we don't want to restrict the survey data, so we're not going to put a data polygon. The nulling. The idea of the nulling by angle length is to remove the long slender triangles on the external edges of our project, and we will do that with the default values, so we'll put on Apply Nulling. Then we'll select Triangulate. Now just before we do, you'll notice that the minimum and maximum values of our data is displayed. The idea here is that if you had some zero data or some very, very high data, that you would recognize some data errors before creating your tin. So we'll select Triangulate. It just takes a moment to do. To take a look at this tin, we'll come across and we'll hit the plus button and add on the tin survey. Now you'll notice it's created the triangles, and by default 12D will join the closest points together to form a triangle. If you recall that when we started we turned on this remove bubbles, the idea there was to take 2 points off a break line and look somewhere else for the third. Now right now this tin is drawn last, so it's difficult to see our survey data. So what I'm going to do is to change the draw order. I'm going up to our menu control button here, going down to models, and I'm going to send the models to back, being our tin survey, to the background. Now you can see our data on top of the tin lines. Now the reason I've wanted to use remove bubbles here is anywhere along the center of a river where you've got the center line, you generally do not want to join 3 points together of your center line to join a triangle. Nor do you want to take 3 points to form a triangle off your bank strings. You'd much rather take 2 points off your bank strings, look somewhere else for your third. And that's what the remove bubbles option does for the 12D tin. Our next step is to add some buildings to this tin. Now in this case we're adding buildings, but we could just as well add piers to a bridge or any other type of structure with vertical walls. Now to do this, first of all, is we're going to read in a cadastral plan of our buildings. So we're going to move up to our File I/O, Data Input, and come down to DWG DXF. Now it's a DWG file that we're planning on reading in, and it's called Buildings. Now every layer inside AutoCAD becomes a model inside 12D. In order to keep our models together inside our model list, we're going to give a prefix to this. And the prefix we're going to use is just DWG1 followed by a space. Now we're going to use default values for the rest of these. Select Read, Finish, and then we're going to add these new ones on. To clear up our screen a little bit, let's toggle off our first of all, toggle off our vertices. Then we'll toggle off our Z values so we can see everything a little more clearly. And finally, instead of looking at the triangles, we're going to go to Toggle and turn on our tin contours instead. Now, to see the buildings that we've just brought in, we'll come up and add on the model called DWG houses. Now, the word houses came from the name of the layer inside AutoCAD. Now, you can see there's a set of buildings here, here, and here, and what we're planning on doing is taking these 2D representations of the buildings and turning them into 3D images. In order to do this, we're going to go up to our Tins menu, come down to User, and select Create Buildings for Tins. First of all, we have to select the model that contains those footprints of our houses, DWG1 houses, and this routine is going to create two new models for us. One model that has the roof and the floor in it, that will become the 3D building, and another model that has only the floor. We're going to use that floor footprint to weed out any survey data inside this area, so that will not become part of our new composite tin. Now, we do need a tin, however, so let's select our survey tin. What that's going to be used for is the bottom of our building. So this string is going to be, first of all, paralleled out just a little bit, in this case 1 millimeter, and then it's going to be draped onto the ground surface to form the base of it. Then what we're going to do is we're going to find the highest point along that string and add 5 meters to that to make the top of the building. Now the colors, we're going to color these strings and later use these same colors for coloring the building. So we'll select Process for this. It says the process is complete, so let's select Finish, and then we'll go on and look at fencing or removing the survey points inside our building. Before we add the new models to our tin to create our new tin surface, we do want to get rid of these survey points that are in the center of our buildings. If we didn't, essentially the roof of our building would collapse down to the level of these survey points. So in order to do this, we're not going to use the DWG houses that we brought in, but rather we're going to use the building floors that were created from the routine. Now the reason we're using the building floors is that these are paralleled out that 1 extra millimeter to make sure that we get all of the data. Now to do the fencing, we're going to go up to Utilities, down to Fence, and then we're going to use the multi-fence function. We're using the multi-fence because we have more than one polygon to do the fencing. Now first of all, the data that we're planning on fencing is only the survey data, so we can go and select that model, Survey. The model of our fences. Now I could go and pick that by selecting our model selection button and coming down and picking our building floors, or I could have done a middle mouse button in that field, meaning same as, gone and picked one of the strings, and then it would have loaded the property off that string we're looking for, namely the name of the model. Hitting the enter key or middle mouse to accept, that would have filled in the same data. Exclude the model from the data, the fence, well that would leave out this. We'll leave that. And what we're looking for is all the survey data on the outside. So I'm going to create a new model, and that new model is going to be just called Survey, and I'm going to call it Outside or Fenced. It's up to you what you choose for that. And then select Fence. Now that's quite quick. You'll find that if we now go on, turn off our survey data, come back and add on the model called Survey Outside, you'll notice that this new Survey Outside has no data inside our buildings. We are now ready to create the composite tin that will include the survey data and our buildings. So we'll move up to Tins, once again select Create, and this time, once again, triangulate data. We'll give a function once again, call it Buildings, and a new name for our tin. I'm just going to call that Survey and Buildings. Hit Enter. The color, we'll leave that as green, and once again we will use the Remove Bubbles option and move over to the data. Now I've got a choice here. We definitely can't use the model field because our data sits in more than one model. We could use the View and then add the models we want to triangulate onto a view, and that's the one we're going to use this time. And we're going to use view number 1. Now that means we're going to have to turn off the models that we don't want to use. Well, for starters, we're definitely not going to use the building floors, and we're not going to use that tin survey. What we're planning on using is that other model that we created called the building floors and the roof. Now, to see the effect of this, we have to zoom in very, very closely. I'm using my roller ball straight in. And what you can see here is on the external, we have a string that's 1 millimeter away that's been draped onto the surface. The other one is a 2D string, which is the top of our building. Now, we do want to include that in there. So now what we have is our data all on one view and view number 1. Once again, we're going to use the null by angle length, and we'll select triangulate and select finish, and you can see it very quickly created our tin. Step in this process is to color our tin using the colors of our strings. This is very effective for presentations using our visualization software, where you can apply textures to the tin using the colors. In this case, we're just going to use the colors. So we'll move up, and we're going to go to tins, down to color, and we're going to color within polygons. Now the tin we're going to color is our survey and buildings, and the fast method is perfectly fine. We definitely want to use the color of the polygons. That's the white and the blue that we've created. The mode that we want to color, we definitely want to color on the inside. The routine that we used was also very careful in the order that it created the strings. It created the outside floor one first, so that when it colors everything inside, and then it created the roof so that the roof is colored second. So using the colors is going to work very well for this. Now, for our next one, we definitely want to come down here to use a model of polygons, and the model of polygons once again is our building, floor, and roof. And we'll select color. Now that colors that very quickly. If we'd like to see that in our plan view, we can come up and add on our tin survey and buildings, and that shows it as contours. But then if we go up and toggle on our tin solid, you can see the coloring that's taken place. If we were to zoom in very, very close, you would start to see the blue image that's been colored between the green, the blue walls, and the white roof. Now that we've finished creating our tin, let's take a look at it in a 3D perspective view. To do this, we're going to move up to View, down to New, and selecting our OpenGL view. Onto this OpenGL view, we're going to add our new tin survey and buildings, and you can see that we've got our buildings here. Now it's shown initially as the triangles, and let's maximize this and go and change that so that we toggle on our shading instead. And now it becomes very clear where we've created our buildings. And if we'd like to zoom in and take a closer look, rather than using the joy control from previous versions, we're going to use the orbit control. Now the beauty of the orbit control is, first of all, if you want to zoom in closer, you can use your wheel. So just by zooming in with the wheel. The other thing with the orbit control is it's very easy to grab your surface, to rotate it, to get different perspective views of those buildings. Our final step is to import a raster image or an orthophotograph to drape onto our tin and to use as a background image. To do this, we'll move up to Strings, go down to Rasters, and select Create. Now the type of raster image we're bringing in is a TIFF image, and then we have to go find the file. It's not located in our working folder, so we're going to have to browse to find that file. We'll have to first of all move up twice in order to get to our training folder, then go into the design area and the getting started basic. Now the final file is inside the user library. 1064 is the one we're looking for. Now you'll notice that once it's picked up that raster file, it's loaded up the size in pixels and the color depth inside that file. Moving over to the Location tab, 12D needs to know the real-world coordinates of this image in order to place it correctly. So this format comes in an Esri World file, and if we select our folder, it takes us straight into the same folder that we browsed for the image, and it's going to be 1064.tfw. Selecting that, you'll notice it brings in the coordinates of the photograph, but also the real world size. Now the real world size happens to be the same as the pixels, so 1 pixel in this case is 1 meter. We now have to decide where this is going to be stored. Now it's going to be stored in a model called rasters, and it's going to have the name train 1064. So if this data hasn't been typed in yet, you'll have to type it in now. Now we would like this photograph to be draped on top of our tin, so this is the point where we get to pick the tin, Survey and Buildings. And then we get to select Create. Now it creates the image immediately and decodes it into something that can be draped onto our surface. Selecting Finish, and you'll see when the view is redrawn that we now have our photograph draped onto our surface. Now anywhere that the surface is not the original green color, so where our buildings are, the photograph is not draped. So if we zoom in just a little bit closer, well, let's go back and do a fit on that. If we just come back and zoom in just a tad closer on this, get in there a little bit better. Sorry about the mouse there and the zooming. Zoom in a little bit closer, you can see now it's very easy to see the building when the striking contrast blue against the ground identifies the location.